Okay, we have some blank axes, very common type of question this on the IGCSE papers, and we have f of x equals 10 cos 20x, so quite a complicated function for x is between minus 15 and 15 inclusive, so it gives you this fixed domain. Right, we have been asked to, on the diagram, this is the diagram, sketch the graph of y equals f of x. Part B, find the coordinates of the local maximum and minimum points. You get 3 marks for that. Part C, on the same diagram, sketch the graph of y equals g of x, where g of x equals the absolute value of x plus 2 for the same domain, x is between minus 15 and 15 inclusive. And finally, you need to solve f of x equals g of x. So this is all a calculator problem. It's really, really common to get questions like this on IGCSE papers, so let's go for it. So the first thing to note is that when you are doing calculator problems like this, graphing problems, the window is the most most common source of mistakes is to do with your window. Now you can see you're given that the values of x that you're interested in this function are between minus 15 and 15. This is confirmed looking at the axes. It's giving you this space to draw it on, and you've got this minimum value of x minus 15 and maximum 15 already on there. It's actually been generous enough to give you the y values. Now that normally does happen, but it doesn't always happen. So if it doesn't, then you're going to have to do a bit more work with your window vertically. But as is often the case, you get all 4 values that are going to make up your window. So if I just draw a little dashed line around here from these extreme values, just to illustrate a point I'm trying to make. So if we kind of do a less box, imagine this is a screen, that's not the straightest, but it doesn't really matter. Around there, now basically that is the window that you're looking at. That will be what you need to make your calculator screen. So once we've told it to graph this function, f of x equals 10 cos 20x, we're going to say, well, this is the bit of the function I want to look at. This is what the screen will show me. So if we now move on to the actual graphing of the thing, so to start up, obviously you turn the thing on, and then the first thing you need to do is realize that this is a trigonometric thing. In fact, if you're in an IGCSE exam, it's almost certain that somebody will have come around, they'll have reset your calculator, and your calculator will be in its default radian mode. So you absolutely cannot have it in radian mode. And if you're dealing with a trig function, you certainly can't have it in radian mode. So what we need to do is go to mode on the calculator, and we need to have a look. So mine is indeed in radian mode. I need to make sure it's in degrees. So if you plot this using radians, it's not going to look right according to the mark scheme. So then we just go quit. And then we're going to actually type in the function. So you go to y equals at the top, and we're going to press 10 cos 20x. So 10 cos, and I'm going to just put 20x, and I'm going to close the bracket. Okay, so I'm going to press enter, and then I'm going to go to graph. So I can see a graph appearing already, and it looks okay, but I haven't done anything about the view window, so be really, really careful. If you don't practice these, or you haven't done enough before you get to the exam, you're very likely just to copy that down. So what you need to do now is press window up here, and these 4 key values, x min, x max, y min and y max, they need to correspond to minus 15, 15, minus 15 and 20. So I'm going to put that in. So x min minus 15, x max 15, y min is minus 15, and y max is 20. So then I press enter for the last one. I don't care about changing anything else on that. So there are many other features, but we don't need to worry about those. So just press graph, and you can see you've got a function that is the same shape. It looks pretty similar to before, but now this is exactly what you can get down on this on your board here. So on your paper. So I'm just going to get rid of that imaginary screen I drew. And so I need to transfer what I can see on this screen here. I need to transfer that onto there. So key features, looking at it, it looks like we've got a sort of a hump, and it looks like it's on the y-axis. And remember, this is 20 at the top, so it's probably around half of that. So it doesn't have to be exact for the sketch, but it's probably a point around there somewhere. If we look at these two minimums, or minima, I've got one on the left, one on the right. They look quite symmetrical, and they look probably a little bit more than halfway down. So it's probably around here and around here. I'm going to have my minima, something like that. And then we look at these end points. So it's sort of probably halfway, vertically halfway between the x-axis and the height of the maximum, something like that. But it's certainly not so crucial for these. So I'm probably going to say one of them's maybe there and one's here. And then I need to just get this sort of nice smooth curve going on. So I'm going to come round like this, and I'm going to come up, and I'm going to go all the way up to here and look to turn the hump down to a minimum and back up again, starting to curl a bit. So now that isn't perfect. You can see it's a bit kind of kinky in there, but it would absolutely be good enough for full marks. So the sketch, I've seen many sketches that really don't look very nice, and they do enough for full marks. And I've seen a couple of quite nice and shapely ones not get full marks. It's all about getting the key things in a key place. So these are very important features of the graph. The two minimums, the minima and the maximum, need to be in the right. This looks like it's on the y-axis. We will confirm that shortly. So it needs to look like it's there. These 2 points, they need to be roughly in the right place. But when I say that, they need to kind of be the right side of the axis. So if you had drawn this point kind of over here, that would be a big problem, and the same for this one. If your end points, say, were below the x-axis, that would probably lose you a mark. But if they were a bit higher, that would probably be okay. Another thing people do a lot, they seem to extend beyond the window. Really try not to do that. Do try and chuck the function off at the end points. Right. The part B, find the coordinates of the local maximum and minimum points. So I can see I've got a local maximum here where I turn around, and I've got a local minimum here and here. So looking at the calculator, I need to find this point, and this point. And the way you find maximums and minimums is with this second calc. So second calc up here. And I'm going to start with the first minimum. So I'm going to go to number 3 minimum. And it's asking me for a left bound. So what that means is you need to take your cursor or your pointer so it's definitely to the left of it. So I'm going to keep going left, 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 left. And I'm going to make sure I'm definitely to the left of that. So I am there. You can go further if you want. It's going to ask me for the right bound. So with the right arrow, I'm going to make sure I'm the other side of that. Then it's going to ask me to guess, and I'm just going to press enter. If you want to try and put your cursor really close to the point and press enter, that's fine. The reason why you sort of have to guess, say in that bound I just picked the left and right, there were 2 of these minimums, it would pick whichever the one was closest to where I guessed, but I never select where there's 2 anyway, so it should be okay. So now I just click enter for the guess, and it's telling me there is a minimum when x equals 9 and y equals minus 10. So x equals minus 9 and y equals minus 10 is your minimum point, or the first minimum point. Right, so now I'm going to go back to the calculator. I'm going to find this maximum. So second calc, and I'm going to find the maximum. So I'm going to, again, the left, right, and guess, so make sure you're to the left of it. Press enter, move the cursor, make sure you're on the right. Definitely on the right now, and then just press enter again. And it's telling me I've got a maximum at minus 3.669 times 10 to the minus 7 and 10. Well, the y coordinate definitely looks like 10. You do want to watch out for the things like this that do happen on calculators, because they're kind of using numerical methods to get it. Now, that number, minus 3.669 times 10 to the minus 7, is a really, really small number. I believe this number is 0. So if you're not sure about that, one thing you could do, you could use the trace function and you could see what the value of y is when x is 0. So if I press trace, in fact it's come up already, but if it didn't I would just press 0 and enter. And it's telling me that when x is 0, y is 10. That number was so close to 0, it is 0, I'm going to write 0 in there. Okay, so now I'm going to find that final minimum on the right hand side, so second calc, and we're going to find the minimum, so you should be used to it by now. Left, right, guess, so come across here, make sure you're left of it, enter, make sure you're to the right, enter, and then just guess. And I've got this rolling nines again, so it's telling me x equals 8.999988 and y equals minus 10. So y definitely equals minus 10. So I reckon that number is 9. And if you think about how, if you know a bit about how cosine and sine graph works, you should know this is kind of symmetrical anyway. But what I'm going to do, I'm going to use the trace function and I'm going to type in if x is 9, what is y? So I'm going to put 9 in there. And it tells me indeed that when x is 9, y is minus 10. So this point is 9. So these are very nice numbers. If, say, they weren't nice, if they were sort of nasty decimals that don't obviously round to a whole number, you should give answers to 3 significant figures unless otherwise stated in the question. Right, next part, on the same diagram, sketch the graph of y equals g of x, and g of x equals the absolute value of x plus 2. So we need to draw it on these same axes. So we go back to our calculator, and it's not going to be too bad. I think the biggest problem is probably going to be knowing where the absolute value sign is. So we go to y equals. I'm going to keep that y1. I want to keep the original graph, just for scale and perspective for one thing, and also because of question D, I'm going to need it anyway. So I'm going to go to y2, as in the second y equals function that I'm plotting, and I'm going to put the absolute value of x plus 2. Now, absolute value can be found in math, and if you go across to number, for number, it's actually the first one, ABS. So if I click enter there, you can see it's given me my absolute symbols. I want the absolute value of x plus 2, so I'm going to type in x plus 2. And I'm going to press enter, and then I'm going to go to the graph. Now you can see that we've got another line appear on the calculator. So looking at that, and hopefully you know enough about absolute value functions to know that a simple linear one like that basically never goes negative, so it kind of reflects when it hits the x-axis. So you can see this key point in here. You could find it if you like, but the fact, because we're only sketching, I need to make sure that point where it hits the x-axis is between the axis and the other graph. So I need to make sure it's somewhere in here. So I'm just going to put it here, and I'm just going to think about where the endpoints go. Well, it's probably about halfway up or a bit more, as in on the way to twit. So between the x-axis and the 20 is probably around halfway. You could sort of compare the height to the height of the hump. It's a little bit higher than the hump, so if the hump's here, it's probably somewhere like here, and the other side looks exactly the same. So I'm going to go up to there, and then I just need to draw lines as straight as I can, but you certainly don't need to use a ruler for sketching. Just sort of make them touch like that. And actually at this point I'm going to label them, so I'm going to call this g of x. And I'm going to call the original function f of x. Okay, final part. Solve f of x equals g of x. Now, when two functions are equal, so remember this is 10 cos 20x, so the black line needs to be equal to the absolute value of x plus 2. Now when these things are equal, when their y values are equal, the same, for what value of x do these functions give the same value? So that happens in two places. It happens here, they are equal, and it happens here, basically where the lines cross, where the lines intersect. So we need to look for intersections of our two lines, and we do that using a calculator. So we go second calc, and we are looking for number 5, intersect. And here it asks you for the first curve, and when it does this, assuming there's just 2 lines, you can just press enter, enter, enter. It's going to start on one of the lines, so you can't maybe obviously see that, but it is on the curve, it's on the cosine graph. If you're not sure which line it's on, just kind of use the side arrows, and as I go right, you can see it's following that line. So I'm just going to press enter. The second curve, it's just automatically moved itself onto the straight line. I can confirm that, so that's fine. Then it's asking me to guess. So when it says guess, I need to put it near the first intersection or the second one. Now, just looking where I am at the moment, I'm probably better off. I'm over here somewhere, so I'm going to guess the second one. In fact, I'm just going to press enter because I'm very close already. And you can see it's found that point, x equals 3 and y equals 5. So then I'm only solving f of x equals g of x, so I'm only actually interested in the x value, so I'm going to write down x equals 3. So that's one of the answers. I need to find the other answer, so I go back to my calculator, second calc, and I'm going to go to intersect, and I'm going to say, yep, first curve, second curve, and then I'm going to have to do some work with the cursor to get nearer to the other intersection. There we go, and that's telling me x equals minus 3.94053, y equals 1.9405297. Now I don't care about the y for this particular question. It could have been worded in a different way so that I would need it. It could have said what's the coordinates of the points of intersection. In that case I would absolutely need y. However, it's just said solve f of x equals g of x, so I only need to give the x value. It doesn't ask me for a certain value of accuracy, so I'm going to use what I default accuracy for almost everything, minus 3.94, 3 significant figures, equals minus 3.94. And that is the end of the question.